Let us start today's session. Okay, this is the week 12 assignment. We are going to solve some more question on this topic of state space analysis. Okay, so in the last class we have actually covered that is how the solution to the state equation. So let us start from that. Solution to the state equation. So here actually last I have told you that x star equal to ax plus bu. This is a non-homogeneous state equation, right? And what is the solution for that? The solution for that is given by actually x of t in time domain, which is nothing but L inverse Si minus A inverse, okay, into x of 0, okay, plus L inverse Si minus A inverse into B into U of S, okay. This is the total solution for this non-homogeneous state equation. In the last class, we have solved one problem related to the homogeneous state equation, and now we are discussing some more problems on non-homogeneous state equation, how to solve the state equation. Okay, so this part is called ZIR. Okay, this is called zero input response. Okay, and this part is called your ZSR, zero state response. Okay, zero state response. Okay, so let us solve one question related to this. Okay. So one equation is given by, let I am giving you the state transition matrix to you. Okay, this matrix can be from a state and block diagram or from a signal flow graph. But I am giving you the, already in the last class we have discussed how to find out the state matrices. Okay, A, B, and C matrices uh, for differential equation, for uh, signal flow graph, from block diagram reduction. Okay, so I'm directly giving you the state matrices to you. So it is given like that: x star equal to 0, 1, 2, 3. Okay, 0, 1, minus 2, minus 3, x plus 0, comma 5. This is b matrix, and this is multiplied with u. Okay, and here x of 0 is given to you. X of 0 is given to you 1, 0. Okay, and here y also given to you 0, 1, x. Okay, so now you can clearly see x star equal to ax plus bu. ABC matrices are given to you. Now the solution you need to find out for this. Okay, the solution is basically your ZIR plus ZSR. ZIR is a zero input response when input is 0, and second part is zero state response when state means initial condition is 0. Okay, so that I have discussed in the last class, what is ZIR and ZSR. Okay, so first part you have to find out what is the solution ZIR and ZSR. Already I have told you that. You can see the ZIR is L inverse Si minus A inverse x of 0. So first of all we have to find out what is Si minus A inverse and take the inverse Laplace transformation of that. Okay, so first solve this part. So what is Si minus A? What is Si minus A? Anyone? What is Si minus A? Si minus A is given by S minus 1, 2, and S plus 3. Okay, this is Si minus 1. I is the identity matrix. Okay, multiplied with S minus A matrix is 0, 1, minus 2, minus 3. You just differentiate, just subtract it, and you'll find out Si minus A. Okay, after finding out Si minus A, then you need to find out what is Si minus A inverse. Okay, so what is Si minus A inverse? Si minus A inverse is nothing but adjoint of Si minus A divided by determinant of Si minus A. Okay, and take the Laplace inverse of that. Okay, so I'm just directly writing here. You just follow. If you have any doubt, then tell me. This is 1, this is okay. And what is the determinant of that? Determinant of this is nothing but s square plus 3s plus 2. Okay, so this is your si minus a inverse. Now what you do, you just simplify it. Okay, just simplify it. So it will be s plus 3 divided by this part. This term can be partial fraction, and it will be s plus 1 and s plus 2. Okay, I'm just splitting every term, okay, on the matrix. So 1 divided by s plus 1 comma s plus 2. Similarly, minus 2 divided by s plus 1 comma s plus 2. And here this term is s divided by s plus 1 comma s plus 2. So this is the overall matrix now. Okay, now take the inverse Laplace transformation of that next part. Okay, so I'm just writing here. If I take the inverse Laplace transformation of that matrix, then it will be how much? Okay, so it will be 2 into e to the power minus t minus e to the power minus 2t, e to the power minus t minus e to the minus 2t minus 2 e to the power minus t plus 2 e to the power minus 2t, and here this term is minus e to the power minus t plus 2 into e to the power minus t. Okay, so this part is your inverse Laplace transformation. Now what you have to do, then what is ZIR? Zero input response is nothing but L inverse Si minus A inverse into x of 0. Okay, so multiply with x of 0. Here x of 0 is given to you 1 comma 0. Okay, this x of 0 is 1 comma 0, so I'm just writing here. Okay, so if you write down this, 2 into e to the minus t minus e to the minus 2t minus 2 e to the minus t plus 2 into e to the minus 2t e to the minus t minus e to the minus 2t divided by minus e to the minus t plus 2 into e to the minus t, and this value multiplied with 1 comma 0. Okay, because this term is nothing but x of 0. Now what is the solution? The solution will be just multiply a matrix multiplication. This will be 2 into e to the minus t minus e to the minus 2t minus 2 e to the minus t plus 2 into e to the minus 2t. This part is your ZIR. This part is your ZIR, right? So someone wants to join, let me check it. Okay, just a second. Share the screen again. Now, what is you have to find out ZSR. What is ZSR? ZSR is nothing but L inverse Si minus A inverse B into U of S. Okay, so I'm writing down here S plus 3 divided by, already this term we have found out, S plus 2, 1 divided by S plus 1 and S plus 2 minus 2 divided by S plus 1 and S plus 2, and here is S divided by S plus 1 and S plus 2. Okay, this term we have to multiply with B and E of S. B is nothing but 0 and 5 is given to you. This is V matrix. Okay, and E of S is unit step response, so this is multiplied with 1 by S. Just multiply all and take the L inverse. Okay, Now L inverse. If you simplify this one, this will be 5 divided by S into S plus 1 into S plus 2 divided by 5 divided by S plus 1 into S plus 2. Okay, you can check this term just to multiply matrix multiplication. Okay, if you multiply 1 by S here, this will be 0, and 5 by 1 by S, this will be 5 by S, and then again multiply here and this term. Okay, you take the L inverse of this, okay, separately. Use partial fraction. I'm not doing here because you know how to do partial fraction. I'm just writing the answer for this. Okay, plus 5 by 2 e to the power minus 2t, and 5 into e to the power minus t minus 5 into e to the power minus 2t. This is your ZSR. Okay, the total response is what? X of t I told you. This is nothing but ZR plus ZSR. Zero input response plus zero state response. If you add these two matrices, then the new matrix will be x of t equal to 5. Okay. What is that matrix? Can anybody please tell me? 5 by 2. Okay. 5 by 2 is there. Minus 3 into 2 minus t plus 3 by 2 to a minus 2t. And the second term will be this one. Okay. This is your x of t. Now you know, after finding out x of t, y of t is nothing but 1 comma 1 is C matrix is given to you, and x you already know. Just place x value here. This is x means x of t. Put this value of x here, and your y of t equal to simply 3 into minus 2 minus 3 into 2 minus 2. This is your answer of the final response. This is the final response of the system. This is the final response of the system. So these type of questions will come if a non-homogeneous system is there and you have to find out the system response. Okay, so let me solve one more question. Okay, one more question. So what is basically so after you find out y of t, now if you take the Laplace transformation, you will get the system response. If steady state error, they will ask you to find out. In what you just simply find out the steady state error. Okay, and check whether it is a proportional. Proportional gain is there, or suppose you check this positional error constant or velocity error constant. What type of input is given? This is a unit step input. So for unit step input, you know that if type is greater than input, then the steady state error is 0. Type is equal to input. Steady state equal to some value we have to find out. Okay, and if type is less than input, then steady state error is infinity. So based on that, this question also, if they ask to find out the steady state error, so you can find out. Okay. Let me go through some questions related to um, controllability and observability. Okay, that is also an important part here. Okay, let's solve some question. So this question you can solve. Suppose a system is given to you 2 comma 0 minus 1 comma 1 and multiplied with x plus b is given to you. B is given to you 1 and minus 1. This is you. Okay. Then y is given to you 1 comma 1 comma y equal to cx. Okay. B is 0 because transmission term is 0 unless otherwise there is no active element in the system. Now check the controllability of the system and the observability of the system. So for controllability, what I told you, find out a matrix that is called controllability matrix, which is nothing but B and AB. Okay. So form B and AB. So 1 comma minus 1 is B. Okay. Then A multiplied with AB, then this term will be 2 and minus 2. This is the matrix. Okay. This is the matrix. Find out the determinant of this matrix. Q of C determinant. This gives you minus 2 plus 2, that is equal to 0. So QC determinant equal to 0. So the system is not controllable. System is not controllable. Okay. Sorry. Look into this problem. Let me go to find out what is the observability. Observability is same. You have to find out an observability matrix which is denoted by Q of O, which is nothing but C and CA. This is a 2 plus 2 matrix. Okay, so you have to form if 3 cross 3 matrix, then another term will be added CA square. Okay, so by this 2 plus 2 matrix, we'll consider only C and CA. Find out C and CA. C is nothing but 1 and given. Multiply C into A, that will also 1:1 will come, and you can check the determinant of Q not equal to 0. Okay, so this means the system is not observable. Okay, let me solve another question. Okay, let me solve another question. Let me solve another question. After contributing and observability, we'll solve one question. Okay, so let's say question is given to you. X1 star, okay, X1 star is given to you minus 2x1 plus x2 plus u, and another equation is given x2 star equal to minus x2 plus u. Now, first of all, you have to find out the state matrix x1 star comma x2 star. Okay, so from this equation, if you find out the A matrix, then the A matrix will be minus 2. Okay, and this term is 1. This term is nothing related to x1, so it will be 0, and this will be minus 1. And just check that where input is something u, which term is associated with u. The first term is associated with u, so the coefficient is 1 here, and second equation is also associated with u, so here this is also 1. So B matrix is 1 1, and y also you check. Y is given to you in the question. Y is given to you, the y equal to nothing but x1 plus x2. Okay, if y is given x1 plus x2, then y matrix will be 1 comma 1 x1 comma x2. This is a y matrix. Okay, now find out the observability of the system. The observability of the system QO. Okay, first find out the controllability. Controllability Q of C. Q of C matrix is nothing but B and AB. I told you. First of all, frame a matrix which is B and AB. B is 1 comma 1. AB is what? Minus 1 comma minus 1, right? So if you find out the determinant of this matrix, the determinant of this matrix will be 0. If it is 0, then it will be not controllable, right? It is not controllable. Now check the observability. Q naught is the observability, which is nothing but C and CA. Okay, C is 1 comma 1 is given. CA is what? Minus 2 comma 0, which is the determinant of this matrix. Okay, the determinant of this matrix not equal to 0. Okay, you can see it is not equal to 0. So it means it is not observable. It is not observable. Okay, sorry, determinant not equal to 0, so it is observable. Okay, So it is observable. Okay, sorry, it is observable, right? Note down this question. So one very important question. I just wanted to do this question, okay, for you. So let's say x of star is given to you a x of t plus b e of t. Okay, and you know your y of t is nothing but c into x of t. Okay, let me give the matrix to you. A is given to you 0 1, 0 minus 5. This is A matrix is given. B matrix is given to you 0 comma 1, and C matrix is given to you 1 and 0. This is the three matrices are given to you. So here just one theorem you apply Cayley-Hamilton theorem. Apply Cayley-Hamilton theorem to evaluate the state transition matrix and also find out x of k plus 1 for t equal to 0.1 second. This is the question. This is the question is given to you. Okay. So whenever you're going to solve Cayley-Hamilton theorem, so you have to find out the eigenvalues. Okay. So you need to find out the eigenvalues of the system. Now I'm just solving this question. So the eigenvalues. Okay. So for this matrix, if you take A minus lambda I determinant equal to 0, you will find out the eigenvalues. Okay. And for this matrix, the eigenvalues I'm just writing it for you. You just find out by yourself. Lambda 1 equal to 0 and lambda 2 equal to minus 5. Okay. Now, after finding out the eigenvalue, we have to find out the polynomial. So what is the equation of the polynomial now? The polynomial is given by, okay, let's note this is a function of lambda. So this is R function of lambda, which is alpha 0 plus lambda 1 alpha. Okay. Now, to take lambda 1 equal to 0, this implies e to the power 0 is equal to alpha 0 plus 0, right? So from here, you find out what is alpha 0. Alpha 0 equal to 1. Now, when lambda 2 equal to 5, then this time, what is the equation? E to the power minus 5t. Okay, this is the equation. 1 minus alpha 0 is 1, right? I'm just putting the value of here 1 minus, okay, 5 times of alpha 1. Then solve for alpha 1. Alpha 1 equal to 1 minus e to the power minus 5t divided by 5. This is alpha 1. Now, what is the state transition matrix equation? The state transition matrix equation is given by e to the power a of t, which is alpha 0 I plus alpha 1 a. Okay. Which is 1 comma 0, 0 comma 1 plus 0 0. So solve that values 1 by 5, 1 minus e to the minus 5t. Just to solve the equations, okay? Minus 1, 1 minus e to the minus 5t. Okay. Then this will be, the final equation will be 1 comma 0, 1 by 5, 1 minus e to the minus 5t, and this will be e to minus 5. This is your state transition matrix. Okay, this is your state transition matrix. Someone has posted one doubt. Okay, someone has posted a doubt that actually you need to find out the state transition matrix for a electrical network circuit. Okay, I'll do one more question on that. Okay, so let me solve. I just solved one question in the last class, but now I'm just going to solve one more questions that will clarify your doubt. Okay, let me solve that question. Since the electrical network is given, which a resistor R1, an inductor L1, and here is your capacitor whose voltage across this capacitor is given plus minus Vc. Another inductor is there having value L2, and another resistor is there having value R2. Okay, so how to find out the state transition matrix of this electric network? Okay, so I told you that you have to find out the state variables. The state variables are current through the inductor. Let me assume that the current through the first inductor is IL1 and the current through the second inductor is IL2. And the third variable is the voltage across the capacitor. Let's know is Vc. Okay, now what you do, you just write simply KVL and KCL equation at the nodes. Okay, so let me first start this node. At this node, just let me change the color. This node is A. So at node A, you can write the KCL equation which is satisfying. So IL1 is nothing but your IL2 plus this current, let's see, is IC. IC equal to C dVc by dt. This is the equation, first equation at node A. Next, let this voltage is input voltage VI. And if you write a KVL on this loop, then VI should be equal to R into IL1 plus L, this one L1, dIL1 by dt plus Vc. Then from here you need to find out the state equation in differential form, which is IL1 dot, okay, this term mainly is nothing but input voltage divided by L1 minus, simplify, IL1 minus Vc by L1. This is equation number 2. Similarly, write the another KVL equation on the loop 2. Okay, write down minus L2 dIL2, or you can say di2. I have taken di2 there, di2 by dt. Let me check what I am giving. dIL2, I have taken IL2. So just write down, in place of I2, you write down IL2 minus R2 IL2 plus Vc equal to 0. From here, you just find out this term. Okay, this is the differential state equation in IL2. So IL2 dot is nothing but minus R2 by L2 plus Vc by L2. Okay, now here are three matrices. Okay, one is Vc star, IL1 star, IL2 star. There are three equations for you. Okay. Now it is your job now to find out what is A matrix. Okay. In terms of VC, IL1, IL. Right. So find out this A matrix. This is very simple. Just KCL and KVL. Okay. You need to apply KCL and KVL. Find out the matrices ABC. Okay. And someone actually in the last class he has asked me about how to find out the gain margin and phase margin. Okay, so this is very simple. Okay, so I already discussed some shortcuts. Okay, so let me give in questions to you. Okay, let me give in questions to you that how to find out k value to get the phase margin equal to 30 degree. So g of h is given to you. This is k divided by s into s plus 1. It is given to you. So this is simple. You can find out by using formula. Na? So phase margin nothing but 180 degree minus 90 minus tan inverse omega. Right. So phase margin is given to how much? 30 degree. This should be equal to 30 degree. So here you simplify what is tan inverse omega. 60 degree. What is at this point? The omega is called your omega GC, right? So this omega is nothing but your omega GC gain crossover frequency, which is find out what is the value 1.732, right? 1.732. Now find out the magnitude omega into 1 plus omega square. Okay, this 1.732 is nothing but root 3, right? So I'm writing here find out omega GC equal to root 3. Put that value here. We can equate it to 1 to satisfy the magnitude condition. So this implies k divided by, okay, 2 root 3. This value should be 2 root 3 equal to 1. So this implies k equal to 2 root 3 is the answer. Okay. This is the answer for the question. Yeah, I have told you the polar plot. Okay. So for polar plot, I mostly discussed some questions which are based on the first quadrant equations. Okay. So if negative term appear, then how you find out the polar plot? Okay. That actually I have discussed in my extra lectures, but actually some people posted that we need to do one more two questions on that. Okay, so this is a very good questions actually. You know, first of all, I'm just giving an hint. Let us find out some question 1 divided by s into s minus 1. This is g of h is given to you. And in another case, this question g of h is given by 1 by s into minus s minus 1. Okay, there are two questions, and the two questions need to find out the polar plot. So first of all, you have to identify that what is the coordinate system. This is your plus j omega. Okay, right? This quadrant is s plus 1, j omega 1. All the terms are positive, and this term is negative. Okay, so minus 1 plus j omega. So what is the angle contributed by here? In this quadrant, this will be 180 minus tan inverse omega. Okay. Now coming to this quadrant, third quadrant, the storms is all are negative. Okay, so minus 1 minus s, so minus 1 minus j omega. So this will be 180 plus tan inverse omega. Similarly, in this quadrant, this is something like this 1 minus s. Okay, negative s, imaginary terms is negative. So it will be 1 minus j omega. This will be minus tan inverse omega. Okay, simple. You just apply this rule, find out. Okay. Now for the first question, g of h equal to how much? 1 divided by s into s minus 1. So at omega equal to 0, what is the magnitude? Infinity. And what is the phase angle? Just put that at omega equal to 0 here, okay? Just one taking. The question is something like this. 1 divided by s into s plus 1. Alright. At omega equal to infinity, this will be 0 and minus 1. Okay. So what is the ending angle? Ending angle is clockwise, right? Okay. So you can draw the polar plot. This will be something like this. This is the polar plot for the first question. Now come to the second question. 1 divided by s into s minus 1. Now for this question, we need to find out what is phi. Phi equal to minus 90 minus 180 minus tan inverse omega, right? For this way, this term is negative, and for this negative term, this is the angle. Okay, so it will be total angle minus 270 plus tan inverse omega. This is the total phase angle contributed by this. Now, put omega equal to 0. This will be infinity minus 270. At omega equal to infinity, this will be 0, and this will be minus 180. So, ending direction is only required, starting direction is not required, right? So, ending direction is negative, so it should be anti-clockwise. So, how it will be? This will be something like this, okay? Anti-clockwise. Check it out. Figure it out. Come to the next question. The next question I given that 1 divided by s into minus s minus 1. Okay. So find out what is the phase phi. Minus 90 minus 180. So be plus tan inverse omega, right? So it will be minus 270 plus tan inverse omega. This is the total angle contribution. Now we put omega equal to 0 and omega equal to infinity. At omega equal to 0, this will be infinity at an angle minus 270. At infinity it will be 0 and value will be minus 270 again. Oh. Not will be minus 270. This will be omega equal to infinity is 90, right? So this value will be negative, I think, right? This is negative. So this value will be minus 360, right? Now, ending direction. Clockwise, right? Positive, okay. Starting direction not required. So do the polar plot. How the polar plot will be? This will be something like this, right? Clockwise, right? You have to start at minus 270 clockwise and reach at minus 360 and value 0. This is the answer. Okay. If I give you another question, a typical question, just give me s plus 2 divided by s plus 1 and s minus 1. One term is negative here, you can check it out. So for the first step we have to find out the total angle contributed by the negative term as well as the positive term. So the positive term I am just writing for the numerator, this will be tan inverse omega by 2, and first pole tan inverse omega, and the negative term it will be 180 minus tan inverse omega. Simplify it and find out what is omega equal to 0. What is the value at omega equal to 0? Put omega equal to 0, then this will be magnitude. Just find out. Tell me 2. Magnitude will be 2, not minus 2, right? What is the angle? The angle should be minus 180 degree. At omega equal to infinity, this value will be 0 and the angle will be minus 90. Check it out. My angle is minus 90. So what is the ending direction? Ending direction is negative, should be anti-clockwise. Okay, starting direction is not required because one negative term is there. Starting direction is only required when all the terms are positive. Okay, remember that I already told you. So now if you draw the polar plot, then this value will be 2 at minus 180 degree lines, parallel lines. Okay, now come anti-clockwise, ending direction anti-clockwise, make a line which is parallel to minus 90 degree, can reach at 0. This point is 0, this point is omega equal to infinity, and this point equal to omega equal to 0. This is the polar plot, right? Let me solve another question. This GF is given to you s plus 3 divided by s into s minus 1. So first of all, your term is to find out the total angle contributed by all the positive and negative terms. Tan inverse omega by 3 minus 90 minus 180 minus tan inverse omega, right? Now you simplify it, this will be tan inverse omega by 3 minus 270 plus tan inverse omega. So at omega equal to 0, this is infinity minus 270, and omega equal to infinity, this will be 0 minus 90. So ending direction is anti-clockwise. Okay, starting direction not required. Find out the polar plot. So something the polar plot will be like this. Okay, this is anti-clockwise direction. This is omega equal to 0. This point is equal to omega equal to infinity. Okay. Check it out. I am just stopping here. Okay. All the best for you. All the best to all the students for the exam. Okay. So do well. We'll meet again sometimes in the future. Thank you.